This LOS is explain how the value and price of a forward contract are determined at expiration, during the life of the contract, and at initiation. Pricing and valuation of forward commitments. So the first thing that we're going to look at is the pricing and valuation of forward contracts at expiration, okay? And the value of a forward contract at expiration is the spot price of the underlying minus the forward price agreed to in the contract. So we can see VTT here, the value at expiration, equals the spot price at expiration minus the forward price that was agreed to at the beginning of the contract. So that's fairly easy to understand. You enter into a forward rate agreement, and that's to an exchange an asset at a specified price at some certain time period in the future. You get to that time period, what is the value of the contract? It's the difference between what the spot price is and the price that you agreed upon to exchange the asset. So it's easy. So again here, VTT is the value at expiration of the forward contract is equal to the spot price on the underlying at the expiration and minus the forward price, which of course is established at the initiation date of the contract. So remember, the forward price is established at the initiation date of the contract, and the value at time zero equals 0, okay? So we'll do a quick practice question here. Which of the following best describes the value of the forward contract at expiration? The value is the price of the underlying, A minus the forward price, B divided by the forward price, or C minus the compounded forward price. Okay, that question should be fairly easy. Which of the following best describes the value of the forward contract at expiration? The value is the price of the underlying minus the forward price. A is correct because the holder of the contract gains the difference between the price of the underlying and the forward price. That value can of course be negative, which will occur if the holder is forced to buy the underlying at a price higher than the market price. So continuing with the pricing and valuation of forward commitments, now we're going to look at how the forward price is established. The forward price is established at the initiation date of the contract, okay? So we can see it's at time 0, so that's the forward price and it's established at time 0. And what does it equal? It equals the spot price plus 1 plus r to the t. So the forward price is the spot price compounded at the risk-free rate over the life of the contract, okay? Now the forward price of an asset with benefits and or costs is the spot price compounded at the risk-free rate over the life of the contract minus, be careful here, minus the future value of those benefits and costs. So here we have the formula updated to include if the asset has some benefits or costs. So it starts the same. The forward price at time 0 equals the spot price at time 0 times 1 plus the interest rate to the power of t minus the future value of those benefits minus the costs, okay? So I put a little star here. I said the text has a lot of algebra, but a simple example is going to make it fairly clear, okay? And so you can see here they're just using a little bit of nomenclature here. The future price equals the spot price times 1 plus r to the t minus, and you can see this is the symbol that they're using for benefits. This is the symbol that they're using for costs, and don't forget it's the future value, so it's times 1 plus r to the t, okay? So that's an important formula that you need to memorize. I would say first memorize in terms of words, then change it into the symbols, and it's not too difficult. So we're just going to go through a little example here with regards to the pricing of a forward. So here, recall the forward equals the spot price times 1 plus the risk-free rate to the power of t. So in this simple example, let's say that the underlying spot price is £50 and the risk-free rate is 3%, okay? And that the contract expires in 3 months, meaning t equals 3 divided by 12, which is 0.25, okay? So the forward price is easy. It's just £50 times 1.03 to the power of 0.25. We get £50 0.37, okay? Thus, the two parties would agree that the buyer will pay £50.37, that's the future price, to the seller in 3 months, and the seller will deliver the underlying to the buyer at expiration, okay? Now suppose the present value of the benefits is £3 and the present value of the cost is £4. So now we've got some benefits and costs. We have to now use this formula where the future price equals the spot price times 1 plus the risk-free rate to the power of t minus the benefits minus the cost, but it's the future value of the benefits minus the cost. So we're multiplying by 1 plus the risk-free rate to the power of t, okay? So you can see that's what's happening right here. We have got our spot price £50 times 1 plus r to the t minus our benefits minus our cost times 1 plus the interest rate to the power of t, and we get £51.38. So in this case, the forward price, which was £50.37, without these costs and benefits, is now higher because the carrying costs exceed the benefits, okay? So when you can see that the costs exceed the benefits, then the price is going to go up because it's a negative on a negative. You're going to add to it, okay? This learning outcome statement is explain how the value and price of a forward contract are determined at expiration, during the life of the contract, and at initiation. So here we're going to calculate the price, the forward price of a contract established today and expiring in 250 days. Now, this LOS does not say to calculate, but we do have the formula to explain how the value and the price of a forward contract are determined at initiation. This is going to go through the exact math, okay? Level 1 is a foundation, level 2 is the application, okay? So this slide is actually a nice to know, it's not a need to know, and this example is 100% from CFA level 2. But sometimes it's nice to know where you're headed when you're building the foundation, you know? And this example is not difficult, so I think it really will help consolidate your understanding with regards to how the pricing of a forward is done at initiation. It's not that difficult, okay? So let's just go through this. Assume that you own a dividend-paying stock currently worth $150. So that's the spot price, $150. You plan to sell the stock in 250 days. In order to hedge against the possible price decline, you wish to take a short position in a forward contract that expires in 250 days. The risk-free rate is 5.25%. Over the next 250 days, the stock will pay dividends according to the schedule. So in the next 30 days, there's going to be a dividend $1.25. In 120 days from now, there's going to be a dividend $1.25. And 210 days from now, there's going to be a dividend of $1.25. So you're going to get those dividends because you're not going to sell the stock until 250 days. So that's going to be a benefit to you. So what do we need to do? We're going to take that 250 days and we're going to subtract 30 and we're going to get 220 days, okay? We're going to take the 250 days till we sell it minus 120 and we're going to get 130 days, okay? And 250 days until we sell the stock minus the 210 and we're going to have 40 days, all right? So the objective is to calculate the price of the forward contract established today. So here we have the formula. The price of the forward at time 0 equals the spot price times 1 plus the risk-free rate to the time minus the benefits minus the costs times the future value of the benefits minus costs, times 1 plus r to the t. That's the future value of the benefits minus the costs, okay? So here we're getting a benefit. Obviously, the dividend is a benefit, and we have no costs. We have no storage costs, etc. So this part of the equation is out, okay? So first of all, calculating the future value of the spot price is $150 times 1.0525 risk-free rate to the power of 250 over 365. So that's a fairly easy time value of money calculation, less than 1 year. And so we get that part of the equation to be $150.35021. Now what we need to do is we need to calculate the benefit. The benefit, the future value of the benefits, and that's denoted by this algebraic symbol. So that's $1.25 times 1 plus the risk-free rate for the 220 days. Because you're going to get that dividend, you can invest it at the risk-free rate for 220 days. So then plus the $1.25 on the second dividend, invested at the risk-free rate for 130 days. And finally, the last dividend invested at the risk-free rate for 40 days, okay? So now we have the future value of the benefits. So going back to our calculation here, the price of the forward is that future value of the spot price minus the future value of the benefits. And so we get 151.53104, okay? So it's 155.35 minus the 3.81. So I think you'll see that working through a numerical example, even though the LOS does not say to calculate, it says to explain. If you understand the calculations, then you can always explain them to someone. And this is not too difficult, and you will have to calculate in CFA level 2. Okay, so we'll move on to a practice question next. So as I said, if you understand the calculation and you get a theoretical question like this, I think it should be easy, in my opinion. Okay, so which of the following factors does not affect the forward price? A, the cost of holding the underlying. B, dividends or interest paid by the underlying. Or C, whether the investor is risk averse, risk seeking, or risk neutral. So we'll put it into words. The correct answer is C. So we can see here from the that A, the cost of holding the underlying is important to a forward price. And of course, we just went through the example of the dividends, and that's why I did it, because if you walk through an example and you understand the math, you would know B is definitely does affect the forward price. So C, we're looking for the false here, it does not affect. C is correct. The cost of holding the underlying, known as carrying costs, and the dividends and interest paid by the underlying are extremely relevant to the forward price. How the investor feels about risk is irrelevant because the forward price is determined by arbitrage. Okay, nice little practice question. Continuing with the pricing and valuation of forward commitments, now we're going to look at the valuation at initiation date. Recall the previous example that we worked through with regards to the math was working on the price of the forward, okay? The stock price at 250 days from T0, you know. Now we're moving on to the valuation at T0, and recall that when a forward contract is initiated, customarily neither party pays anything to the other. It is a valueless contract, neither an asset nor a liability, therefore its value at initiation is 0, okay? Remember that. So the forward price that the parties agreed to at the initiation date of the contract is a special price, that's that $151 that we looked at in the previous example, that results in the contract having 0 value and prohibiting the arbitrage. Because neither the long nor the short pays anything to the other at the initiation date of a forward contract, the value of a forward contract when initiated is 0, okay? I think we're clear on that by now. Although a forward contract has 0 value at the start, it will not have 0 value during its life. Okay, so where are we heading now? So we started with the valuation of a forward at expiration, and that's fairly easy to understand. It was the difference between the spot price at expiration and the forward price that we agreed to at the initiation of the contract, okay? And that makes sense. Somebody may be a winner and somebody may be a loser. You entered into an agreement to exchange an asset at a set price at a specific period of time in the future. When you get to that time in the future, the spot price may be different than that forward price that you agreed to. Therefore, you'll have a winner and a loser. So we understood that the value of a forward expiration is pretty easy. It's the spot price at that time minus the forward price that you agreed to. So we did that, number 1. Number 2, we understand that the value of a forward at time 0 equals 0. That's the slide that we just did, okay? And then what we looked at previously was the price of the forward, how did we calculate the price of the forward? So we calculated the price of the forward using this formula. Forward price equals the spot price times 1 plus the risk-free rate to the power of t. That's the future value of the spot price. That's the carrying cost, minus the benefits minus the costs, time the future value of the benefits minus the cost. So it's benefits minus the cost times 1 plus r to the t as well. Okay? So now the next thing that we need to look at is the price during the life of the contract. Sorry, not the price. Got to be careful with my language. It's the valuation during the life of the contract. The price doesn't change, okay? So now we're going to look at the valuation during the life of the contract. And again, this LOS says explain, it doesn't say calculate, but you know in level 2, you need to calculate. So here's the formula. So here's the value at time t, okay? Any time at time t equals the spot price at time t minus the future price, which doesn't change, but we're doing the present value of that future price. So it's 1 plus r to t minus t, okay? So this is one thing to note here that, okay, if t equals t, when it's at expiration, then the denominator is going to equal 1, because look at, let's say the risk-free rate was 5%, okay? And it's at expiration, so it would be 1 plus 0.05 brackets, let's say it was 250 days, 250 days minus 250 days, because we're at expiration now. So that would be 1.05 to the 0. And anytime you put y to the x to the 0, it's going to equal 1, okay? So you can see that at expiration, I'm just going to scratch that right out, and I've got my value of a forward at expiration is just the spot price minus the forward times the t. So that's should be fairly easy to understand, okay? I'm just going to erase that here just so you can see it again. So the value of a forward at any time again is, look, it's the same, it's almost the same equation as the value of a forward at expiration. Spot price t minus the forward price, but you're taking that forward price and you're discounting it back, 1 plus r t minus t. And if it's at expiry, t equals t, so we're going to be 1 plus r to the 0, and that equals 1, okay? So the value of a forward contract is the spot price of the underlying asset minus the present value of the forward price. Derivative contracts have finite lives. There's an expiry date. The expiration date is big T. Time small t is an arbitrary time between today and the expiration. So that shouldn't be too difficult to understand the value of a forward at time t during the life of the contract. So continue with the pricing and valuation of forward commitments. This slide is just a little bit of a math review. Understanding the math review kind of helps you explain it, in my opinion, okay? So what we're going to start with is the value of a forward at time t, which is during the contract life. So recall, here's the formula. The value at time t equals the spot price minus at time t, small t, minus the future price that we agreed to. It's the present value of the future price, so we're dividing by 1 plus r t minus t. So at initiation, don't forget the small t equals 0 at initiation. And no money is going to change hands. So the value at time t equals 0 equals 0. So now I can, if t equals 0, I can substitute that in. So 0 equals the spot price minus the present value of the future price that we agreed to, divided by 1 plus r t minus 0, because small t equals 0. It's at initiation, okay? So you can see that in the denominator, we're going to be left only with the big T, okay? So now we've simplified to this row, where 0 equals the spot price at small t, minus the future price that we're agreeing to, divided by 1 plus r to the t, okay? So what I've done here is I've put the this part of the equation to the left-hand side, so now it's a positive, so you can see the future price divided by 1 plus r to the t equals the spot price. Then, just moving the algebra, how do we get it? the future price equals the spot price plus 1 plus r to the t. So that's just a little bit of a math review for you that takes you through the pricing of a future, the valuation of a future, and the value forward. The pricing of a forward, the valuation of a forward at initiation is 0, and the value of a forward at any time, small t, during the life of the contract. Okay? Okay, so we're just going to work through an example for the value of a forward during the life of the contract. So a 2-year forward contract was established with a price of $62.25. Now remember the difference between the price and the valuation. The valuation at time 0 equals 0, but we have a forward price that we've agreed to. Now it's a year and a half later, small t equals 1.5, and the spot price is $71.19, and the risk-free rate is 7%. So now we're going to have a valuation for the forward contract during the life of the contract. And here's the formula. The value at small t equals the spot price minus the present value of the future price, okay? So you can see we have our spot price is the $71.19. We have our futures price of $62.25. And here's how we do the present value. It's 1 plus r, 1.07, to big T minus small t. Big T is 2 years, small t is 1.5, okay? So this is not too difficult at all. We're going to get 71.19 minus 62.25 divided by 1.07 to the power of 0.5. And the valuation that we're going to get, so you can see the nomenclature here, small t 1.5 equals 11.01, okay? Now again, the LOS does not have the math to calculate, but I think it's very handy to be able to understand the calculations. They're not that difficult to understand. And then when you get into the theoretical questions, you know, most likely, least likely, I think if you understand the math 100%, then you usually get the theoretical questions right, in my opinion. So we'll just finish this LOS with one quick, easy practice question. Which of the following best describes the difference between the price of a forward contract and its value? A, the forward price is fixed at the start and the value starts at 0 and then changes. B, the price determines the profit to the buyer and the value determines the profit to the seller. Or C, the forward contract value is a benchmark against which price is compared for the purpose of determining whether a trade is advisable. So I think you could find that question to be very easy because we know the forward price is fixed at the start. The value starts at 0 and then changes. That's why we just worked through all the mathematical, numerical examples. So A is correct. Forward price is fixed at the start, whereas the value starts at 0, then changes. Both price and value are relevant in determining the profit for both parties. The forward contract value is not a benchmark for comparison with the price. And that's the last slide for this LOS. Thank you.